Good morning.
You look like you want the other foot of the slippers.
Sir, you know, say you know English. You still good enough?
We know.
Yes, still good. Me say when I pull up the YouTube for the recording. When I pull up the YouTube for graduation, I must have the dean of applied one now. I never remember.
Pure and
Yes,
applied sciences.
hear my teacher speak is spoken. Come through, Mr. Shine.
Say my apples could use.
What are you always? Wow. That's a never son horse.
Can I tell you, hey, God go down. Hey, I said, me say, when you see the other day in the class, I said, but sir, you still not sound good. And I say, me soon come, I go turn, I have a turmeric and ginger tea bag. And I use that, and it kind of potent, me not like it, kind of really potent. And I add some ginger to it, and some more ginger to it, and what do you call it, the garlic. And I work it, you see, Astanil, I work it, and then when I hear Sunday, when I heard myself coming back, graduation was Thursday, Wednesday, I say, yeah, all right, me now go talk, because I have to go able to present my graduates come Thursday.
Of
So
course.
I'm glad, man. Yeah. But congratulations though. You know, on another note, congrats. I saw that you've completed your EDICO. I reopened one or two more to give you a better opportunity.
Sure.
But thank you for doing that. I gave some thought to your request with the common coursework. You were absent on Friday for 3 hours. I didn't see you, but anyhow, I saw your message to say that you may be late or absent or something of the sort. Something of the sort. So tonight, there are two areas that I must go through. I've been going through quite a bit of the integration, indefinite and definite. Tonight, what I want to do is to look at the area under the curve, and I want to look at and I did some integration of the exponential and the logarithmic function. I'm going to review one or two of those because I feel so that they come.
Yeah, it was shared with me, but I didn't get a chance to.
Okay, fabulous. I'm happy that they shared it. And then now I need to go through the L'Hopital's rule. Well, I know you may have an idea of how that is done, but I need to go through the L'Hopital's rule. I have taken.
That's one thing I don't remember.
Yeah, man, I'll do that. I've taken a decision that I'm not going to look at any differential equations. I'm not going to have the time. So come next semester, I know you guys will survive. You guys will survive and pass the course. You don't have to do that question. Come next semester, because I still have to get the differential equations. Come next semester, I have to start from scratch with the differential equations because I'm really not going to have the time to go through all of that between now and Wednesday because the exam is Friday. The EducaSoft has to be completed because let me tell you what is going to happen. It's a Friday, your exam finish Friday morning about 11 o'clock. I am going to get on campus about 12 o'clock, 1 o'clock, so I can collect the papers and head straight home. And me, the papers, and Jesus will sit down over there to mark up because I have to mark up those papers by Sunday the latest so I can start entering the grades. Thank God it's not a whole lot of you because Monday morning I have to present those grades for them to be ratified so they can be posted. Now, Astanil, the last time around, the stationary point question wasn't poorly answered, but
I never answered on that.
no man, it wasn't poorly answered. It was almost the only one that you really the candidate answer still. So that was only at a 60%. It was 18 out of 30. You cannot afford a 18 out of 30 this time around. You have to give me a 30 out of 30. All right. There are other questions that I know you knew, but I don't know why you froze on the exam.
That's me with exams.
No, man. You can't freeze up on me again because I'm expecting, well, to be honest with you, I'm expecting all of you to move over to to calculus too, because you're not being badly, it's just kind of lazy for me sometimes. But um, I'm expecting all of you to move over to calculus too. This is our first iteration of the block scheduling, and I'm hoping that you guys can move over. So what I want
so
you
that
to
they
do,
can have more block scheduling. Because I really appreciate this.
um, to be honest with you, you were one of those, the group that I had in first semester. I remember when I went to drop off the exam paper, I was I was distraught. And I remember Mrs. Campbell had just put in some braids, and I said, Miss Campbell, I love your braids. Your hair is so nice. And I tell her how she looked pretty, and she just saying, boy, Mr. Shan, thanks. And I said, Mrs. Campbell, she said, what happened to you now? I said, I'm returning the calculus one papers, and I said, we don't have a calculus too. And she said, Lord Jesus, what are we going to do? I said, Mrs. Campbell, one of two things. We either can run calculus one for this semester and then do calculus two in the summer. And then she said, oh Lord, but they may not want to have a summer school, this is some internal stuff. I said, well, the only other option is for us to try the block scheduling. She said, all right, I think that could work. Mark you, if I were to be honest with you, I know I'm being recorded, but it's just the honest truth. For this semester, this class has taken up most of my preparation time. Um, when I say most of my, because I mean I have to be on the ball with you guys because exams is Friday coming. So block scheduling is good. I'm actually doing a research. I'm going to come to you guys to get some, for you to answer some questions. I can put some things in place, but it is good. But Lord, it takes a whole lot of preparation. Just for me to make sure that you guys are ready. But I'm hoping. I mean, this was done specifically for the group last semester. We don't want to disenfranchise you guys. So that's why we did what we did, because there are some students, as you would know, are currently waiting for calculus too. So
Yeah.
this is why we
And you're
know
telling me, Asanil, you gotta do this, you gotta do this, you gotta do this.
absolutely you have to, because I mean you need to join the others who would have gone through already waiting. And I can tell you, there are two students who completed all their assignments already on for calculus too.
Mm,
Yes, man. I mean, that's a completed perfect scores.
that's good.
So, yeah. So I reopened some stuff for you. It's now 8 minutes past. I am really not going to be waiting on the others, because the truth of the matter is, them say who have raw meat, I go see fire, and I am ready.
But
Um,
I must say, I appreciate this though.
yeah, man, no problem. No
Mm,
problem. All right. Go and go sort out this. If I give you 2 minutes, I soon come.
okay.
Dr. Shand, good afternoon, sir. Shashand? Shashand?
All right, guys. So let me share this document. As a quick run through to what it is that we did last time around, we looked at the integration of the exponential function, and in 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 short, what it is that we said is that when we integrate in the exponential function, once it is that we have, sorry, once it is that we have the natural logarithm here, it is going to be the integral of the exponential function is the exponential function itself. So if you look at it, e to the ax, when you look at your answer, you're going to have e to the ax in it. So how do we get this now? We're going to differentiate the power. We're differentiating the power. Ax. Ax. When we differentiate ax, we're going to get a. We're going to reciprocate that. So instead of just having a, we're going to have 1 over a. 1 over a. And then we have to find ln now. Once it is that we're differentiating the exponential function, we're going to have ln of the base. So this one going to be ln e, this one going to be ln a. See here? So when I differentiate b, x, I'm going to get b. See? 1 over b, ln this number, ln a. When I differentiate ax, I'm going to get a. See it? 1 over a, ln e. And then you just put back the exponential function right here, so plus the c. You put back the exponential function right here, so plus the c. However, ln e is equals to 1. See it right here? So right here, I can just say, you know what? Convert this to 1 here and say 1 times a is a. So this one here reduces to 1 over a e to the ax plus c. Once it is that the base is any other number or term other than E, the ln of that number will have to be there. And incidentally, A is greater than 0 and it's not equals to 1. So it's going to be like 2 and 3 and 4 and 5, whatever the situation is. All right. So for example, let us look at 8, the integral of 8 raised to the 2x. The integral of 8 raised to the 2x. Let me pause. Are you all hearing me?
Yes, sir.
Okay, good. So let us look at a 8 raised to the 2x. What is going to happen is we are going to differentiate the power. When we differentiate the power, what do we get? 2. Very good. So it's going to be 1 over 2 ln what?
8.
Very good. Ln of the base, which is going to be 8. So it's going to be 1 over 2 ln 8, 8 to the 2x plus c. So remember, this is going to be 1 over 2 ln of the base, and the base in this case is 8, so it's going to be ln 8, 8 to the 2x plus c. Do you agree with me now? Somebody answer me, please.
Run another one, sir.
All right. Do that. All of you do that one for me, please.
Sorry, the 8 in the answer, the 8 2x, not the ln x, you know, the 8 to this
The 2x?
second part, yeah.
Mm-hmm.
It's in a different line from the fraction going across, right?
Yeah.
All right.
It's like having a fraction multiplying by a number.
Yeah, that's what I was asking.
Yeah.
So we'd have 1 over 3 ln 10, and then 10 3x, 3 to the third x power, if that's how we call it, plus 3.
Plus c.
C.
Yes, ma'am.
Sir, so we're going up on number 10, this one.
Number 10 is just very ugly, but it's the same thing. This is the exponential one. So when we find ln of e, we're going to get 1. So once it's e, we don't have to put ln here. All we do is just differentiate the power and put 1 over it. So this one is going to be 3x squared minus 8x plus 1. So it's 1 over the differential of the power times the original question. So this is times e to the x cubed minus 4x squared plus x minus 2 plus c. So just remember, you're differentiating the power, then you're reciprocating it, and then you're writing out the question. You know what I just remember as we're speaking? And I'm looking to see if I did. I had promised you the last class on Friday that I was going to send off some stuff for you. Did I send it, yes or no?
Let me double check.
I'm looking in my snaps. I normally copy them in my snaps, but I'm not seeing anything here in my snap. Just check for me, please, and let me know.
No, I didn't get anything after
I didn't get
Friday.
anything on. Okay. All right. Because I did promise that the rules for the integration, or maybe that's why the document was still open. I did promise. Okay, so let me just pause right here. I did promise that I was going to send off the rules in particular for integration. It just came back to me, but hold on. I thought I did, but clearly I didn't. All right, let me. Okay, so what is happening here? All right, take you all. Oh, that's right, because I'm clicking the wrong one. mm, all right, while I try to get this thing sorted out for you, let me just remind you, students, some of you are moving nicely with Educasoft, some of you are not there at all. Not there at all. All right, so I've just sent you the things that I had promised you. There is something else, that I never sent with that. There is something else. What am I looking for? I just got distracted a while ago. Was supposed to send the laws as well. The laws as well. Okay, there you go. All right, so those are the two things that I promised you. Yes, but let me go back to this Educasoft piece. I don't want anybody to say Mr. Shanti is wicked when 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 the stuff close out on, because I have been asking and begging and beseeching. All right, resume sharing. Okay, let's go. For tonight, I at the top of the class, I shared, Asilian and I were present, and the only ones present, and I was sharing some ideas with her. I have a few more areas to go through. I have decided to myself that there's one of the areas that I'm not going to be doing now. That area also comes in calculus 2. when I get to Calculus 2, I have to just sort myself out. When I get to Calculus 2, I have to just go and run the pair of them. The students who will be in Calculus, who are already waiting for Calculus 2, would have gotten that bit of information. So I guess it won't hurt them to get a review of it, but I won't be doing it with you because I'm not going to have the time. Tonight, my aim is to go through integration by substitution, integration under the curve, and to look at a little bit of L'Hopital's rule, and to look at a little bit of L'Hopital's rule. All right. And when I'm finished with that, pretty much based on what I would have seen and prepared for you, that would be it. And I'm hoping that come Wednesday, I can just summarize everything. So I really need to complete everything tonight, so that come Wednesday, I can just summarize nicely, and then we just seal it up for Friday morning.
When is the mid-semester?
So I would have given you something over the weekend, but there was some programming assignment that you guys had that was due last night or over the weekend. So I did not do that. So I will talk to you towards the end of the class about it. By the way, I could maybe just do it now. Do you have class immediately following my class?
What?
Do you have a class immediately following this?
Yes.
Do you have a class? What class do you have tomorrow? What classes do you classes you have tomorrow?
Tomorrow we have programming and custom management.
Okay, and then Wednesday they have
calculus and computer
and
program.
computer. All right. So this is what is going to happen then. I prefer to do it maybe tomorrow, so I can get it, mark it, and then give it some feedback for
Sir,
mhm.
if it's like a multiple, if it's straight multiple choice, sir, I think we can do it tomorrow, sir.
No, it's not multiple. It's not straight multiple choice. No, that much I can tell you. No. All right. So what I'm thinking tomorrow, yes, I'm thinking for you to be tomorrow. You know, so I will have it opened. Say about. I mean, I'll open it for about 2 hours. It's really a 1 hour piece, but I'll open it for 2 hours. But I know you guys work. Ouch. And I don't want to have it there just lingering, because it really is supposed to be given on the examination conditions. So I have to kind of restrict it somewhat. So what I'm thinking is I'll open it, say 9 p.m. tomorrow. After your cost and management, you will just take a little breather, do it. Tomorrow is Tuesday. Upload it by 11:30 thereabout, I'm thinking. Then I will mark and to have it ready for you guys Wednesday night, so we can go through, you know, because some of those that I'll be giving you on the mid-semester would be on the final exam. So that's my thinking. Let me hear your suggestions. Quick and fast.
That's one quick
I
question.
agree.
Okay, thanks, Aston. Mario, you saying what?
Will it be on Edicasoft or Canva?
I'm going to put it on Edicasoft. Yes, I'm going to download it from Edicasoft.
Okay.
Any other question? And of course, you're going to upload it. It's just like how what I would have done with you, like that Friday and that the other day in class where you copy it and put it into a Microsoft Word document or PDF file. That's exactly how you're going to do it. Don't send me the raw photos. I'm not able to download those to mark. All right. So we're using the same format. So you're going to send me one single document with the stuff embedded in it. Fair enough?
Yes, sir.
All right, thanks much. Let's go. So integration by substitution. I do expect something like this to come. It's really not difficult. It's just for you to make a quick substitution, integrate as per usual, resubstitute, good to go. Let's go. So I'm going to do an example here with you. It says by using the substitution, u equals 2x plus 1. Normally, they tell you what the substitution is. Normally, they tell you what the substitution is. They don't leave it up to you to go and figure out and say, oh Lord, then suppose me to just use 2x. No, they will tell you what the substitution is. So it says by using the substitution, u equals 2x plus 1, find the integral of x times 2x minus 1 to the 4th power. So this is what we're going to be doing. And I want you to work for me. Undivided, please. Undivided. Purpose-driven today. So this is the question. The integral, upper limit is 1, lower limit is 0. X times 2x minus 1 to the 4th power dx. We're using the substitution. Oh. I have this there because this is another question that I have down here for you. Yeah, that one. And I didn't want to move this. So don't pay what is highlighted in the mind yourself. This is just another question for you to work. But what I'm going to do, I'm going to reduce this so that I can have it projected so that at least you can see the question. So, you know, if you know what I'm talking about. I think you do. Right? So don't pay that in the mind yourself. That's another question for you to do in a few. So the question says, by using the substitution, u equals 2x minus 1. We have to use that. It tells us that if we use, we have to use it. So I'm going to let u be equal to that as it told me. Then I'm going to find du by dx. So du by dx is going to be equal to 2. Because when I differentiate all of this, Shomari had a question last time around, sir, we're doing integration. Why is it that differentiation have to come into play? Yes. You would have seen just now that the integral of the exponential function that I have to differentiate the power and then reciprocate it. And if the base is e, I don't have to put ln e because ln e is 1. But if the base is a number, I have to put ln of that number. That's just a rule. So yes, there are questions when it is that we're integrating, we have to do some differentiation in it to help us out. We looked at 2 types on Friday, and here goes another one now. So we're differentiating. When we differentiate, we can get 2. I put this 2 over 1, and then now I have 2 fractions separated by an equal sign and cross multiply. Du by 1 is du. Du by 1 is du. And 2 times dx is 2 dx. So why do you put that in blue? Because I'm making a substitution, so I want to change dx. So I'm going to make dx a subject. So what I'm doing, I'm dividing both sides by 2. When I divide both sides by 2, I'm going to have du over 2 equals dx. See here, so du over 2 equals dx. So remember to make dx the subject of the formula. Remember, we're making dx the subject of the formula. So now, I know that it says I'm supposed to use u as a substitution for 2x minus 1. So I know this can be u to the 4th. I mean, no, so this is going to be du over 2. Then, sir, we are going to do for that x here. Well, let us see what will happen. Now, so what we're doing, all of this here, this 1 is x equal 1. This 0 is x equals 0. This are x. All of this is in x, and all of this is in x. So the whole function is in x. So if we're making a substitution in u, we have got to change out everything in u. So this already changed out in u. We know we can change out this in u. This one, something I forgot to do with it. And this one, the upper limit and the lower limit, also has to change. So if we're making a substitution, u equals 2x minus 1. We have the upper limit here, and have the lower limit here. So we're substituting the value x equal 1 in the upper limit and the lower limit. But let us look at the upper limit first. The upper limit is 1, says u equals 2 times 1 minus 1. And 2 times 1 is 2, minus 1 is 1. So the new upper limit here is going to be 1. But sir, wasn't it 1 before? Yeah, so we had to substitute and work it out because you can work it out and it don't come out to be 1. Let us work the second one. The lower limit now. The lower limit is x equals 0. See down here, sir? 0. So I'm substituting into my substitution here. 2 times 0 minus 1 is minus 1. See? The lower limit never come out to be 0 this time. It come out to be minus 1. So my new upper limit is going to be 1, and my lower limit is going to be minus 1. Sometimes, when you work it out, this number is smaller than this one, but remember, your upper limit is always a bigger one, and your lower limit is always a smaller one. So whichever one it works out to be bigger, that is your upper limit. Whichever one works out to be smaller, that is going to be your lower limit. Remember, the upper limit is always going to be a bigger number than the lower limit. All right. Follow me so far?
Yeah, most of it.
Good. Now, I am substituting. So you see my x here, and then you see my times 2x minus 1 to the 4th times d of x. The upper limit here is 1 and 0. Look at what? I'm substituting my upper limit. The same 1 remains 1. And the lower limit now move from 0 to negative 1. See it here? This x is going to be here. All of this now becomes u. See, u is equal to 2x minus 1. So it becomes u to the 4th. And my dx becomes du over 2. So I'm making a full substitution. And then again say to me, but sir, why everything is in u away from the 1 here? Yeah. So I have to now recall. I have to now recall and say, u is equal to 2x minus 1. So I need to work out this for the value of x. So I can change out this x because I can't integrate this with u x so, u so, u right so. No man, everything I forgot work out to be that. All right. Now, so what is going to happen now is I'm just going to do a transposition. U is equal to 2x minus 1. So I'm going to add 1 to both sides. I'm going to get u plus 1 is equal to 2x, and then divide both sides by 2. So my x now is going to be u plus 1 over 2. See here? U plus 1 over 2. This x is this x.
Go again.
Remember, u is equal to 2x plus 1.
Yeah,
So I'm making x the subject of the formula. So I'm transposing. Look at the transposition. I am adding 1 to both sides, so I can get rid of that minus 1. I'm adding 1 to both sides. And when I add 1 to both sides, I'm going to end up with u plus 1 equals 2x. Tell me that you agree with me.
Okay, yeah, I'm seeing that.
Good. And then now, I want to make x the subject of the formula. So I'm going to divide both sides by 2. So I'm going to divide this side by 2 and this by 2. I'm going to have u plus 1 over 2 is equal to x. Tell me if you see that.
Yes, sir.
Good job. So this x now is going to be substituted for u plus 1 over 2. See it right here, so now? So if you look at this function here, every single thing inside here so is containing my u. Sir, this looks even worse than the question before. Really? Not really. Because what is going to happen now is that this 2 times this 2 gives me this 4. And this u plus 1 is going to now be multiplied by this u to the 4th. So Aston asked a question earlier, and I was going to explain to her like that, but I didn't. She says to me, sir, is this 8 to the 2x in line with this thing? And I said to her, no. This is like a fraction being multiplied by a number. And she said, okay, that's what I thought it was. Because this 8 raised to the 2x could be multiplied by this one to give you 8 raised to the 2x over 2 times ln 8. But I didn't do it like that because I wanted you to see the relationship with what I have right here for the answer. So that's why I didn't do it like that. All right. So don't worry. Don't be too alarmed at it. It is really the same thing. It is really the same thing. What is the same thing? This u plus 1 we multiply by u to the 4th. See here, u plus 1 we multiply by u to the 4th. And once I have 4 in the denominator here, it means that it's a quarter. This 1/4. Please note that I'm carrying my new limits, upper and lower limits. Then I'm going to multiply u to the 4th by u plus 1. And also that 1/4 is a constant. So u to the 4th times u is u to the 5th. U to the 4th times 1 is u to the 4th. So you see, because it's a constant, I can take it out. Remember, when we're doing integration, I sent you the notes just now. When we're doing integration, I said to you that once you integrate in a constant, you can remove the constant, do the integration, and then multiply the answer by what it is that you factor out. This is a perfect example of it. Right? So we can therefore take it out. And this is rule 6 of the set of rules that you now have. And then I'm going to integrate my u to the 5th. Remember that when I integrate, I add 1 to the power and then divide by the new power. Add 1 to the power and then divide by the new power. So I'm going to add 1 to 5. I'm going to get 6. So I'm going to have u to the 6 over 6 plus u to the 5th over 5. Tell me if you agree with these two stuff.
So, sir, why you never put, just as I said,
Just as I said, what?
why didn't you put recall after the recall that you have there? So just as we have the recall notes for the quarter as a constant, why you didn't put the recall to say that when you add 1 to the power and divide by the new power?
I could.
That would be what? Rule number 7?
No, 3.
Okay.
That would be the third rule that I gave you on the paper, which really is the basis of integration. Just adding 1 to the power and divided by the new power. That is really and truly the basis of integration. All right? And then remember now, from the stuff that we've been doing on Friday, Friday's class was very productive because remember, I just presented the questions and you guys worked. And you guys did pretty well at working on those. We've already integrated. Now we're going to be applying the limits. So anywhere in the function here, you see u, you're going to put 1. So it's going to become 1 to the 6 over 6 plus 1 to the 5th over 5. And then you're going to subtract it now. There is a subtraction sign here every single time. Then now you're going to substitute the -1 in the same set of the same function. So it's -1 to the 6th, see here, over 6 plus -1 to the 5th over 5. Really and truly, I shouldn't have this here again because I would have applied my limits before. So this needs to be removed. 1 to the 6 is 1 over 6. 1 to the 5th is 1 over 5. -1 to the 6 is +1. So that becomes +1. Watch this too. -1 raised to the 5th power is a negative number. So this positive sign here changes to a negative sign. And when I remove these parentheses and say 1 over 6 plus 1 over 5, and distribute this negative sign as negative times a +1/6 gives me a -1/6. And when I multiply these two negative numbers here, I get a +1/5. My -1/6 will cancel with +1/5. And I'm going to have 1/5 plus 1/5, which is really 2/5. But I want to show you the rule. Recall that from rule 6, that a quarter is a constant, so we can take it out. So you see, we take out the quarter, and we take out the quarter, and we take it out, and we take it out, and we take it out. You see, we've done the question right here, so remember, say, that quarter, I forgot to multiply the final answer. So 1 times 2 are 2, and 4 times 5 are 20. 20 itself goes 1 time, and 20 to 20 goes 10. So my answer is 1 over 10 unit squares. Or if you want, you can say 2 into 7 goes 1 time, 2 into 4 goes 2 times, 1 times 1 is 1, and 2 times 5 is 10. Same difference. It's not difficult. Sorry, go ahead.
Do that cancellation again?
I said 2 into 7 goes 1. Hold on. Let me write it. Hold on.
Mm-hmm.
Hello?
Sir, why are you disturbing my class? So what I'm saying to you is that negative, that positive a quarter, that positive a quarter is going to be divided by, is going to be multiplied by the 2/5. So this is what is going to happen. So I have 1/4 being multiplied by 2/5. 2 into itself goes 1 time. 2 into 4 goes 2 times. 1 times 1 is equals to 1. And 2 times 5 is equals to 10. So I'm going to have 1/10, which is what I have here as the answer.
Okay.
Remember, once it is that you're doing an integration, you're going to have unit squared.
Okay, before we got there, right? The previous step, you cancel out the 1/6. Because I'm assuming that
That's
from
positive 1/6.
right.
You can add it to negative 1/6, so they cancel out.
Oh, so that's the reason I would do it. Okay, all right.
Yeah, because remember, no, this negative, and think about it. There's an imaginary 1 that is right here. This negative 1 multiplied by a positive 1/6 will give me this negative 1/6. And this negative 1 multiplied by this negative 1/5 will give me a positive 1/5.
Okay.
But what I want you to see though is this important. When you raise a negative number to an odd power, your result is always going to be equal to something that is negative. When you raise a negative number to an even power, your result is always going to be positive. So this 5 and that is being raised by -1 is going to give us a negative answer, a negative result. So that's why this positive sign, let me use a different color. That's why this positive sign was changed to a negative sign here, because you're raising a negative number. You're raising this negative number to an odd power. Negative number is being raised to an odd power. That's why. Very, very important. You can't forget that concept. That concept is going to haunt you. It's going to haunt you if you don't do what it is that you're supposed to be doing. It's really going to haunt you. So once you raise a negative number to an odd power, your result is always going to be negative. Once you raise a negative number to an even power, your result is going to be positive. Your result is going to be positive. Fair enough?
Yeah, fair enough.
All right. Let me work. I did say that I have a question there for you, but let me work this one with you. I want to work this one with you. And this is, let me use a different color so that you can. So this is not, this is Question 2. That's question 2. So the question says the integral 0, 1, x squared 5x cubed plus 4 to the third power d of x, and it says to you, use u to be 5x cubed plus 4. The question asks you to integrate using a substitution. If you integrate otherwise, you get 0 mark. You have to follow the instructions given. You have to follow the instructions given. All right? Now, the first thing I'm going to do is to find du by dx. When I find du by dx, what do I get? Talk to me. Du by dx, what do I get?
That's
So this is where we do the substitution of the u
Mhm.
with the equation.
I want you to tell me what is du by dx, right? Differentiating du by dx, and what I come up to write.
After a minute now.
oh my dear son. 15x.
Huh?
15x.
Hold on.
That's incomplete, you know. 15x is incomplete.
Plus 4.
Mm-mm. Oh, what the exam Friday?
Sure, give me a second. Let me just check
Okay.
the notes.
Okay.
I'm going meds. Hold a second.
This is calculus 2.
1. No, seriously, guys. When I differentiate u equals 5x cubed plus 4, what do I get?
My bad, sir. 15x squared.
Thank you, sir. I didn't want to drape you through the computer while you know. And I said, I can't believe say you were working the question so nicely with me on Friday. And you're gonna give me full answer. All right, yeah. So 15x to the second power. Everybody say that?
Sir, Mr. The differential, but I'm gonna see how, like, we're just working the u first, and then we do the substitution.
Oh, you say the differential?
Yeah, I see
Oh.
where the 15x come, but
No, tell me say the 15x squared because 15x is not the
15
correct answer.
I see how we have arrived at the 15x square.
Okay, good. So go and work with me now. We're doing it in stages.
Okay.
So put it in over 1. We have 2 fractions separated by an equal sign. We always cross multiply. So what I'm going to have now is du times 1 is du, which is equal to 15x squared dx. I want dx to be the subject of the formula, so I'm going to divide both sides by 15x squared. All of this cancels with all of that. So dx is going to be equal to du over 15x squared. So we have this one already. We know this one because all of that is u. So I don't have anything for this yet. All right, press pause. And I'm going to tell you why. You see when I reach right here, so you notice that I put in all my substitution first and then I see what I have. And then I recognize now that I still have this X right here, so that I need to put out. And then I had to go to my recall. So we're going to set out everything like this after we finish, before we move on. So we need to look at the upper limit. Remember, we're doing a substitution. So we need to look at the upper limit. The upper limit is when X equals 0. Our substitution is U equals 5x to the third, 0 to the third, plus 4. So U is going to be equals to 4. So my new upper limit here so far is going to be X equals 4. U equals 4. Tell me that you see that.
Yeah.
The return is kind of silent, but never mind. I will continue because I have to move on. And then now for my lower limit, I'm going to have X equals -1. So I'm going to have U equals 5 times -1 cubed plus 4. Here it goes again. I'm raising a negative number to an odd power. My answer is negative. I'm raising a negative number right here, so to an odd power. My answer is going to be negative. So this we're going to work out to be -1. So -1 times 5 is -5. So we have U equals -5 plus 4. U equals -1. So that's my new lower limit. So my lower limit was 1. It is now -1. So look at what I'm going to have for the question now. And everything that you see over this side is a question that I'm reworking for you. I want to work it so you can see what is happening. So this is going to be my integral now. My integral is going to be upper limit now is going to be this 4. Lower limit now is going to be this -1. And then I'm going to have this x squared. I write it because I want to see what I have. And then all of that says that I'm supposed to use this as u. And this is going to be to the third power. My dx now is going to be du over 15x squared. So I'm making a substitution. Let me highlight all the things that we're going to be using. I'm highlighting all the things that we're going to be using. U equals 4, U equals -1. And then we're going to have dx is equal to that. So all of these is what we're using. All of that is what we're using. So I'm making that substitution in it. All right? I'm making that substitution in the stuff. Now, watch me now. I am now recognizing that there is a x squared down here that can cancel this x squared up here. So I don't have to make that that step that I did in the first example. I don't have to do it for this question because it so happened that x squared cancel out. Sir, what are you talking about? Remember in this one, when I wrote it, there was nothing here to cancel this x. So I had to go and make another substitution. In this case, when I set out everything and I look at it, I recognize that this x squared can cancel with this x squared. So look at my new function. My new function now is going to be the integral for u cubed du. And that's it. Because the x squared cancel out, I'm only left with u cubed. The du is here because, oh, sorry, over 15. Didn't we see the 15?
Oh,
Over 15.
I was just going to ask you if it cancels
Yeah, over
the
15.
15
No,
and
it's just
no.
no, it's just the x squared cancel out. So it's over 15.
Okay.
So look at what is going to happen now. 15 is a constant. I'm not going to integrate no constant. I
Well,
mean,
that's
no
the
maths.
answer.
You're going to factor out the 1 over 15, don't it?
Hold a second.
Go ahead.
Why you didn't put the 15, the du over the 15 instead of over the u? Or it doesn't matter?
The du over the 15.
Because we have du over.
Oh, same difference. Same difference.
squared.
Same
Oh,
difference. Same difference.
okay.
But remember, but agree with me that the 15 is in the denominator. So I can't factor out 15. I have to factor out 1 over 15.
Right.
Good. And if you look at this side, you see my u is equal to 4 and this is equal to 1. So it's the same answer we're coming out. And then now, let us go back now to integrating this. So I'm going to have 1 over 15. And I'm integrating u to the third. So I'm going to get u to the fourth over 4. You add 1 to the power, divide by the new power. My upper limit is 4, my lower limit is -1. You add 1 to the power, you divide by the new power. See it here? Oh, it's so far it reached? Geez, it's all right. We have enough space. That answer is all the way down there because I was doing lots more explanation, right? So we've now integrated that. So what we're going to have now is going to be 1 over 15. U is 4, so it's going to be 4 to the 4th power over 4 minus -1 to the 4th power over 4. Because remember, it is always the upper limit minus the lower limit. It's always the upper limit minus the lower limit. All right? So now, 1 over 15, 4 to the 4th over 4. Anybody want to work out that for me? What is 4 raised to the 4th power divided by 4 equals? Do that for me, 15. I think I have 63 in my head.
64.
64. That's what I meant to say. 64. Everybody with me with 64? Háblame, 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 háblame.
Hold a second. No. Let's go again with what we're supposed to be adding, please.
What is 4 raised to the 4th power? Then you divide that by 4 and so much you get.
-64.
Mm-hmm. Let me show you a grown-up way that I did it to get the 64 at one shot. I said side work 4 to the 4th over 4. That is 4 to the 1st power. So I said, you know what? This is going to be 4 to the 4 minus 1. It's going to be equal to 4 to the 3rd. And 4 to the 3rd is 4 times 4 times 4. 4 4 is 16 times 4. It's going to be equal to 64. Talk to me now.
See,
Nice job. AC, what's it?
So the 64, but I feel like you're running left me though.
How so? You see the 64?
Yeah.
Mm-hmm. Where I run gone either.
The U to the 4. So in the previous step, so
Mm-hmm.
we substituting for the low and the upper, right?
Mm-hmm.
We have the 1/15 that's here. We have, oh, okay. Add the power and divide by the new power.
Very good.
Okay, sir. Get you back. Or me get you back, whichever one.
So adding the power divided by new power is from this step up here now.
Yeah, that's what I realized.
Right, yeah, man. And then we're not finished. So
Minus.
the integration finished right here, so I'm just going to apply the limits now right here, so
Mm-hmm.
right.
And
Negative one raised to the fourth power is what number? Tell me what number it is.
4.
Excuse me, ma'am.
What?
Negative one raised to the fourth power is
Minus 4, sir? No. Sir, minus 1.
you look like you want you look like you want the other foot of the slippers.
It gives a positive 1
Thank you, please. Why is it positive?
because we're multiplying let me tell you, sir. Let me tell you what I say. Let me tell you what I say. When raised to a negative, when raised a negative number to an even power, the response is always positive.
Good. So you see this negative 1 is being raised to the positive 4.
Positive 4.
Mm-hmm. Mm-hmm.
Okay. And that right there in the bracket is the lower level that we minusing.
Mm-hmm.
Okay.
Wow. 64 minus a quarter. Mm-hmm. 64 minus a quarter equals what again? 63 and 3/4.
So 5, yeah.
Multiply all of this. 63 and 3/4 divided by 15. That's my answer. It.
Four and a quarter, or maybe not. Yeah,
You got 4 1/4.
yeah. I feel
Anybody
like,
agree?
no. I feel like it's wrong though, but 4.25 is not 4 and a quarter.
Mm-hmm. So we get 4 1/4 unit square. Let me just check to see my answer is correct. 4 1/4 is the same thing as 17/4. Check for me, please.
Yes, it is.
Good job. We so bright. We so bright.
No, we still learning.
Same answer. Same answer. All right. What I'm going to do is
Can you pause for a second, like off the topic?
I'm going to pause by giving you, I'm going to send you this. No.
Okay, while it's sending, can you give us a strategy for practicing
Strategy for practicing. All right.
for the exam?
Can I do that on on Wednesday. I'm going to tell you why.
Can I do that today?
I want to finish off this tonight. And then now come Wednesday, new pace. I have sorry,
Maybe you misunderstood strategy.
mhm.
What I'm asking is not the topics that will be coming or you think might be coming. What I'm asking is, how do you suggest that we start? Like, practice questions. Like, I'm not sure what I'm asking, but I'm sure what I'm asking. So I need to start practicing, but I'm not sure how to start.
Start with your
There is
stationary
so
points.
much. Okay.
Start with your stationary points.
Okay.
That is going to come and it's going to come with for enough marks. So start with your stationary points. You get that out of the way, then you move into like your rockstone. But I thought I did it. I just saved it. Okay. I just saved it. Start with your stationary points. Then you're going to move into substitution, integration by substitution. Yeah, but I just saved it. Save. And then, oh, come on. Okay, open. Sorry, I'm just trying to get this document to you because towards the end of that document that I just sent is a question that I want to practice on your own. So yes, Asin. So what I want you to do is just attempt your stationary point question first. For your mixing message, you're going to get things like first principles differentiation, limits, and piecewise function. Those two I want you I want you to practice for Friday. That's why I want to mark the papers.
Repeat that, sir, please.
Limits, piecewise function, stationary points is what you should be tested on for the mid semester. But those are also going to be coming back on the final paper. So that's why I want to give you the paper beforehand so that you can work those questions for me. I can mark them and I can give you feedback on Wednesday in preparation for the final exam. Fair enough? But if you understand your stationary points, you should be able to pick up quite a bit of marks. Could be 20 marks, could be 30 marks. I don't know what number it is. But quite a bit of points. You come out of the exam Friday unless you pass it.
Friday's semester?
Huh? Yeah, Friday's the end of your semester. They haven't been back scheduling. Remember, you are Calculus 2 begins Monday, March 4. Everybody here, so for Calculus 1 is expected to be moving forward to Calculus 2. I am expecting you over. Now, it's one thing when I expect you to move over, and you don't put in the work in order to move over. I have more of you here now. Let me repeat what I started off at the top of the class. So there is one student who has completed all of the pieces. There is one student who has 2 more assessments to complete. There is one student who has only done a piece of assessment and has quite a number of assessments to go through. And there are others of you who are halfway. I'm saying to you, I cannot extend EducaSoft beyond Monday because Monday is the start of a new course, Calculus 2. The prerequisite for Calculus 2 is Calculus 1. So what I'm saying is, if you don't put in the work and you don't pass Calculus 1, you cannot be sitting in the Calculus 2 class come next Monday, God's willing. I'm sorry, I have to say goodbye to you. But none of you should be in that position because I would have covered so far about 85% of the syllabus. More than enough for you to go into the exam, pass it with an A. Pass the course with an A. So I depend on you. So do me a favor now that you have received the PDF document I sent to you just now. I want you to attempt that question for me that says using u to be 3x squared minus 5, find the integral of 5 upper limit, 2 lower limit, 6x times 3x squared minus 5 to the third power.
So, Sean, can you look in the chat?
Sir,
Yes, please.
afternoon.
Afternoon.
Is it Thursday morning or Thursday night?
For what? For what?
Sir? Erico
Thursday morning,
close.
Thursday night, for what?
Erico closes.
My preference really would have been 11 o'clock on Friday morning when your exam would have been done, because once your exam done, it's done. But I think I left it open until Friday afternoon. Since I know I'm not going to finish marking the papers by Friday night, I left it open until Friday night. Is that okay? Or would you like me to close it out on Thursday?
Oh, sir, I have no problem, you know. No mega push to finish it up. That's why I'm ask.
Friday
Okay.
night is good, sir.
Okay.
You know what's even better?
What, sir?
Sunday night is even better. Much
Okay.
better.
Let's get going. There's a question. Let's get going with that little one question for me, please. Quick and fast. There are two other areas that I want to look at. Those short, they're short areas. Stepping away for half a second. Super. happy. We learn the word tonight. I'm not asking. All right. Okay. Okay. Mhm. Or we still?
Still working.
Still working out. Are you experiencing any difficulties or are you okay with the working out?
Sir, I think I have a little difficulty. However, I'm trying to figure out if my final answer may or may not make sense first before I conclude to that.
All right. Do you think? Or the rest of the stay?
Same, sir. Same.
Okay.
All right, my final answer not gonna make no sense.
Okay. What is the difficulty? Talk to me.
Sir, for the upper level, I
The
got
upper
the new upper level,
what did you get for the upper level?
70. Let's see what that makes sense.
And what you got for the new lower level?
7.
And you are correct.
But sir,
Just do the Aston, stop doubting yourself, my love.
all right, it's not doubting. However, I'm not
Mhm.
sure if there is a value for DU. So sir. So when
What do you mean you're not sure if hold on. What do you mean you're not sure if there's a value for DU?
sir, all right,
What is DU?
let me tell you what I have, right? I'm not confused myself. So I have
Just no, but before you go, just tell me what you get for DU.
no. Sir, I love him,
Never
but
mind.
not laughing. So I got DX. I'm
You get
somewhat confused where DX and DU is concerned at this minute. I got the DU. I made DX the subject of the formula. So I would have DU over 6x.
So what is the problem? You are correct.
Yes, I understand that I'm correct. But if I'm confused, I'm not correct. Because
You know, so I'm gonna give the other slippers, you know. No, but Asenil, you are confusing yourself, my love, because you're 17 and your 7 is correct, and your dx to be du over 6 is correct. All you have to do, my love, substitute it into the formula, into the question, and replace what it is that you're substituting for. Don't be confused about it,
but
man.
all right, there's some have a problem.
By substituting and something is
Because I cancel the 6x with the 6x from the question.
very good.
And
So
then
what are you left with?
now I'm left with upper level 70, lower level 7, u to the cube. Am I not supposed to have the u beside that?
Yes, ma'am, and you're correct. Du. You remember dx is going to be equals to du over 6x. So when you cancel the 6x from the denominator with the 6x over the other side, you're going to be left with du. Yeah, man. Let me show you something. Look at the screen. Down here, so. You see, I'm happy that you get it, you know. But you're confusing. You're confusing yourself. So everything is now in you. Dependable. Yeah, man. Yeah, man. Go on, dependable.
So my mother should not come from morning. Scroll down. But
No, you're out of my question. Me want you to do it. But students, you know, you're asking it out of order. But scroll down. No, you are going to do the question.
Yes, sir. No, we minus the upper limit from the upper limit from the lower limit.
I mean, how you minus it?
Right.
It's going to be the upper limit minus the lower limit. So you're going to
That's what I
substitute.
said.
Oh, but hold on. You don't integrate it, you know.
So I guess that's where I have the problem.
Yeah, you don't integrate it. So you have to integrate. The rest of you are with the rest of you okay? Are you where Aston is at?
Sir.
Matter of fact, at the first you talk to me in a class in a Simon. Hey boy, Simon, the ramp with the eye, you know. Cause you know it's a Friday, you know, say you're there. Done.
Yes, sir.
All right. You see, I'm just threatening you guys today, you know, because me want to say, oh, I'm gonna put me to the test. Oh, I must pass my exam on Friday. Me not ask you know. But don't worry about it, man. If you come to class and you do the work and you follow my lead, there is nothing that you guys have to worry about. I promise you. there must be something on the exam, but listen to me. Of one thing I'm certain, stationary point is going to be there. If you can pick up your 20 out of 20, or your 30 out of 30, or your 25 out of 25, stationary point can't come less than 20 marks. It's either 20, 25, or 30 marks. If you pick up those marks, you're on your way in passing the calculus one. It is going to come, and there is no other way for me to say it gently. It is going to be there. And there are so many other areas that we've looked at, or piecewise function. Them questions that come for enough marks, 7, 8, 9, 10 marks, right? Your limits. When them man drop limits, them now drop one limit, them drop out 2 limits at 5 marks each. Right? So that's another 10 marks. So just imagine if you get all a question with a full mark question with stationary point, just for argument's sake. And then you get a question where you get 2 limits question and a piecewise function and a piecewise at 10 marks, and you get 2 limits question for 5 marks. That's at 20 marks, you know. At 20 marks, that. And you pick up a 30 marks for the stationary points, and you pick up a full 10 marks for piecewise, and you pick up a little marks for the stationary. At 50 marks, at what a 60 you get already, you know. Who's a bright? Who's a A plus? When you study the book here, study the book. I'm getting excited for you guys because you were taught. One of the things I'll say to you is I quite like this class. My calculus 1, 2 classes never normally give me problems for their online teaching learning. You guys come to the class with a different level of attitude. Sometimes I have a rocks up here, but there is no love lost. And I'm just really expecting big things from you guys. I have nothing. My expectation is up there. So if you give me anything less than what I expect, I'm going to be disappointed. Because my expectation is that you will all pass the course. I'm not hiding. I'm not making up my face. I'm not saying nothing that I'm not supposed to be saying. I'm speaking the truth. All right. So if you want to go and disappoint a teacher, don't let me see our road. All right. Move back. So Aston is there. Shamari, where are you? Are you where Aston was, or you never reached there yet? Or you passed there?
The past there while we did not talk about it.
Okay,
Get
good.
answer.
Oh, so you have an answer, that's what you say?
Yes, sir.
Okay, let me hear what your answer is, Papa. Hey. What is your answer? What is your answer, son?
Remember, just check it.
Simon, I want you to listen, you know, because if I'm off, I want you to tell me, said, no, that's not what I get, sir. All right, Shamar, when you're ready.
6,1,899.75 units square.
And you see, if you don't get an A from a course, Shamari, you have to do it over. If you get a B plus, you fail.
All right, sir.
Okay. You know what you need to go home and start doing tonight for me? Don't you know what it is?
Yeah, I have an idea, sir.
Okay, you better. Don't let me say it because I know you know. Very good. Yes, sir. That's it. Right down to the T. Astonil, Simon, Mario, Sir Hessler.
Yes, sir.
Very good.
Sir?
Listen to me now. I'm going to cut you off now. Where you get for the answer?
Sir, come back around to me, sir. Come back to me.
Mario, where you get for the answer?
Yeah, still have some cases again.
Hey, Mario, you take too long, you know, boss. Exam on Friday, you know. Simon, what say you?
They're so finished.
All right, cool. I hear you.
Mr. Sean, check the chat.
Sir, come here, please. We can go through it now, please.
Timothy, no. I think it's your answer that kind of scary. Timothy, get for the answer first.
Yeah.
Wait for the answer.
The 6,001,899.75 units square.
Big up your good self.
But sir,
Don't question me. Goodbye.
alright.
You're correct. Very nice. Very nice.
Sir, in a
Two
many
down.
things.
No, because that question I did because I wanted to see how well you guys would have worked with that. Yes, the answer kind of big. Hey, just imagine you get $6 million now. $6,189.99. $1,899.75. Could I give you the $1,899.75?
Yeah, but that's why me think it don't make no sense.
Yeah,
Maybe
man.
because-
$6 million. I will how money that, Blow, whoa. Could I get a new car?
Hmm.
I'll pay
Maybe
up.
because I'm expecting it to be a smaller number.
Yeah, I know. I did it that way because, there are times students who said to me, sir, the answer wrong. I said, why is it wrong? Like Shamari was like, sir, no. I got to get for the answer, be confident. I can't tell you what the answer is going to be like for the exam. Well, granted, I don't think they're going to give you a $6 million answer. But I did it that way because I wanted to prove a point to you. Simon, where are we?
I think I missed out a step.
All right, hurry up.
But so you can go through it and see if I can.
No. No, you think you're going to pull off a signal for me? Do my question and tell me answer first, Papa. You not pull off a signal for me at all. Finish it, man. Finish it.
Observe that calmly.
But see, a trendsetter down.
I'll take the slippers.
But easy they know. But excuse me, sir, are we going to? Yes, we are going to have. Yes, we have class. Ah, boy, I tell you.
All right, sir.
One of my fun experiences for last Thursday was just to sit in the graduation and look at students who I knew aren't very bright students, but they are very hard workers, if you know what I mean. Math is not their forte, but them come to the math classroom and give me them 100%. And when I see them walking across the stage, collecting their bachelor's and their associate degrees, all I could sit and say to the other deans, I'm a proud daddy, a happy. And when I see some students who, no, say, God, only God alone could I do that? They say, yeah, me youth, are you that? Right? I mean, there are students, this batch was, this batch was pre-calculus, business calculus, during COVID. So there are students who would come up to me and say, hi, Mr. Sean, I am John. Mr. John Brown? Yes, sir. There are students who I was seeing for the first time at the graduation. They knew who I am, but I never know who they were. And they come and their parents were with them, man. It was just a nice feeling. Very nice feeling. Very, very nice feeling.
Are you
So,
misloaded attack when you say a proudness drop a girl?
oh Jesus, man, it drop on bones and come back. No, man, very nice moment. So when you hear me roughing up, it's not because I'm miserable or me no want good for you. It's because I know what it feels like at the end of the tunnel. There are students who go across the stage and cry, because they are the first in their families to get a bachelor's. Them cry. They are the first in their families to get a bachelor's. The mother helper, them father gardener, them father a higgler. They are the first in their families. So when they come across the stage and cry. So it is a proud moment. So it hot now. It hot, but guess what? Persevere. You can do it. And it starts Friday of this week. Just think about it. Come Monday next week, you'll have one more course to your Aaron profile as a passing grade, and the semester don't finish yet. This is the beauty about the block scheduling. All right. So in one semester, you're doing two math courses in one semester. Right. So come on. I don't know how else to motivate you. Other than just to say, just continue working. Simon, what say you, Papa? Adrian, Mario, what say you?
Yes, sir. You're sure of the class. You're sure of the class.
You sure me sure?
Yeah, man. No watch where you see for Eddie come now, you know. It a touch up, man.
Okay, I hope so. I really hope so. All right, let's go. I think I've punished it enough. So yes, Astonel, yes, the rest of you. Simon, the answer is 6,000,001
Yes, sir, I
eight
got
hundred
that.
99.75. That's what you got?
Yes, sir.
Yeah, man. Good job. Mario and Adrian and France, your answer should be 6,001,899.75 units squared. All right, I'm taking a pause from there because that's the end of that. I am not going to, as I said, I'm not going to touch. I'm not. If Wednesday in a different mood on Wednesday, I will touch those. But for now, no, I am not. This is what unit. Remember your stationary point. Stationary point is very, very important. And you're supposed to tired of me hear me saying that. All right, let me just do this very quickly. I know there are 4 more minutes left, and I don't want Aston to say, sir, do you see the time? Of course, I know she will say it, don't. All right. Okay, and so happen that this is just a one question that I have. This is a one question I have. You know, let me ask you, because if I don't, I would have missed this one. Quick question. Oh crap. Did I do these implicit differentiation with you already?
Yes, sir, I believe so.
Okay. Think there, Shamari, it rings a bell.
Yes, sir. Where when you differentiate what you put dy by dx.
Very good. Okay, I'm very happy that I did. I'm very happy that I did. All right, so I will show you this business about the normal and the tangent. That normal and the tangent is going to be a 2 minutes class. I won't do that today. This is what I want to just finish off the lesson with now. And I just have one question: application of integration, which is really the area under the curve. Right? That's where I want to end the class. And in 2 minutes, I can do this. It is really not difficult. Besides, all of what we just did, what we did on Friday, what we just did a while ago is it's pretty much the same thing that we are going to be doing now. It's the same thing that we've done on Friday, the same thing we're now doing. It's just a little twist. It's just not even twist. It's just a little addition to the question. So here what the question is saying. It says to find the total area enclosed between the curve. Watch me. Find the total area enclosed between the curve. See the curve here? The x-axis. See the x-axis here? And the value is x equals -2. -2 is here. And x equals +2, +2 here. So technically, it's a shaded region they don't want to define. They want to find the area under the curve for the shaded region. How does this become important or necessary? Say Shamari's father never have much to give him, but him say, know what? My one boy, I have piece of land on the beach front, and I'm going to give it to you. Him father don't even recognize what he has done for Shamari. Shamari, no, because him the calculus. Shamari say, no, we're going to calculate the area under the curve. And Shamari calculate this area and recognize that him have this amount of space before we reach water table, we can build underground. And then Shamar say, you know, I'm going to sell a piece of land to the hoteliers, you know. And the hotel people say, yes, brethren, I'll pay you $40 million for this. So poor Shamari father never knows so how much money might give Shamari. Shamari catch $40 million out of that. So the area under the curve is just to see how much space that I have under this particular curve. You notice that most times now when you see apartment complexes are being built and you say, how am I going to get an apartment complex out of this? What the man them do is build a parking space underground. Anybody ever see that yet?
Yes, sir.
Yes, sir.
Yeah, man. Them have the underground parking space. It is so because they don't have enough space up top. And what they do, they just go underneath. So they have this massive parking space underneath, sometimes can hold as many as 20 cars. And then they build on that. So you're pretty much parking in the basement. All right? So the area under this curve is nothing more than them giving you the function. This function, h of x, is x cubed minus 3x minus 2. All you're doing is integrating the function x to the third power minus 3x minus 2, which is the same function here, is the same function here. And see it here, the upper limit is 2, the lower limit is minus 2. Sir, how do you know that the upper limit is 2? The bigger number is the upper limit, and the smaller number is the lower limit. All right? But sir, you have a negative 1 here, yes, because I did the question 2 ways. Sorry, and there's an error right here. It's supposed to be negative 2. See it right here. I corrected it right here. Can you see that?
Yes, sir.
Sorry, you said yes?
Yes, sir. I said yes.
Yeah. So this is supposed to be negative 2. I made a correction here and see it in here that I made a substitution here of negative 2. So all I'm doing is just integrating the function for where they want me to calculate the area under the curve. Tell me if this is different from what we have been doing.
No.
It has not. It is not. It's the same thing that we have been doing. It's just for you now to interpret what it means by the area under the curve. It's just for you to interpret now what it means by area under the curve. Now on Thursday, on Wednesday, God's willing, what I will do is I will show you some questions. We will go through some questions that will help us to put things into perspective as we're calculating the area under the curve right here. We'll go through some questions as we put things into perspective. All right? Are there any questions? I know you have another class. I'm not going to keep you much longer. Let me just give you a little update as to where I'm at. So I have now completed integration with you. What is left is just for me to go through some questions with you now, some exam type questions. I presented the concepts. I also need to do, I didn't get the chance to do my L'Hopital's rule. L'Hopital's rule is really limits, but using differentiation. I promise you it's not going to be difficult. I promise you. I can use 10 minutes and you get it quick and fast because you know how to differentiate and you already know how to find the limits of functions. So all I'm doing is just putting the two of them together, right? And for us to just go through some questions, seal it off. And remember, tomorrow I'm going to release the mid-semester. You upload it to me by about 11 o'clock, 11:30. I will let you know exactly what time. And then I'll mark those, present them to you on Wednesday evening when we're having class. So we can just go through those stuff because I expect some of those questions that will be given for the mid-semester will indeed come back for the final paper. And you do me well. Just let me be very proud of you. Thanks for coming out.
All right, so have a good evening.
See you to my love later.
All right.